Alright, this is our last piece here, and two things about this really big, crazy looking formula. First one is, don't worry, you don't have to memorize. So anytime that we're going to be doing a thing on compound interest, a formula will be given to you. The second thing I want to tell you is that it's a little bit different, slight variation on the textbook. Okay, so I'll just say different than text. Now the textbook will give you the exact same answers. Their definition of R is just slightly different, but let's go through this. So, well, what is compound interest? Compound interest is if you're going to be putting money in the bank, they will, let's say you put $1,000 into the bank, okay, and let's say you're getting 10% interest per year. So the key here is when we're talking about interest rates. Okay, so this R could be your the annual interest rate. Now, when you put money into the bank, if you were to wait till the end of the year, your interest would be equal to 10% of $1,000 would be equal to $100. And then at that point now your $1,000 would turn into $1,100. And if you kept it in there more, you'd get 10% not of your original 1,000, but now, so if this was year one, in your second year, now you would be getting interest off of this $1,100, and you get 10% of that, and so now your interest would be $110. I hope that makes some sense to you. I'm just going to do a little bit of erasing here. Let me see if I can do my fancy erase. Oh, I have to have my erase key. I don't have it. Okay. Alright, so compound interest then is everybody tells you should start saving when you're young, and it's because of this idea of compound interest that you're going to be getting interest on your interest. Okay, so let's do our definitions of how this formula works. A is going to be the amount of money that you're starting with. Amount of money at start. In my quick little mini example, that was the $1,000. P is, oh, sorry, I just completely said that wrong. A is the amount of money at the end. It's like the answer part. Okay, pardon me, at the end. So when you take your money out at the end of some amount of years or time, A would be the amount of money that you have at the end. P is principal, which means the amount of money at the start. Okay, so that in my example was $1,000. At the end of 2 years, that was 1,210 or something like that. Your annual interest rate is R, and this is as a decimal. Now, the next thing about this compound, in my little quick example, I said that the bank pays you interest at the end of the year. That would be something where we would say compounded annually. So there's different, when you get investments or a bank account and things like that, pay attention to how they compound the interest. So compounded annually would be one way. Compounded annually means at the end of the year is where they put interest into your bank account. The N value for that one would be equal to 1. Okay, so if you see those words, N is equal to 1. N literally means the number of compounding periods. If you see the words compounded monthly, how many times a year would the bank be adding interest? It would be adding 12 times. Alright, I'm not too sure how many more other terms you're going to get besides compounded annually and compounded monthly. Another one could be compounded semi-annually, which would be every 6 months or twice a year. So that would be n is equal to 2. Okay, so those are just some different examples of what n value that you might be getting. And it's a little bit of understanding of English. So annually, once a year, monthly means 12 times in a year, semi-annually means 2 times in a year, and so on. So the t would be the number of years. So looking at that formula, let's do example number 4. Kyle invests $1,000 at 3.75% compounded annually. So in our formula, first of all, I can see that P, which is how much money that we have to begin with, is going to be equal 1,000. We don't know what A is. That's what we're going to try to find out. Our R value is going to be 3.75%, so we're going to take our 3.75 and divide by 100 to turn it into a decimal. So the decimal moves over 2 places, so 0.0375. You'd be surprised at how often people make little mistakes. So, just sort of mentally you can think in your head, it's like, did I move it over 2? Yeah, if I start at 3.75, I go to my 2, I got it. Okay. What else do we have here? The compounded annually. Compounded annually means that it's going to be once a year, so I can say here that n is going to be equal to 1. So let's write our formula. So something like this, we got our A is equal to P times 1 plus R over N, all to the power of NT. So A is going to be equal to 1,000 multiplied by 1 plus, so now our R is 0.0375 divided by 1, so it's just simply 0.03375 multiplied by n to the power of t. And since n still is 1, it's the same thing as t. So t here is our variable, and a, like our x value, and a is what comes out of the function. We can actually tighten this up a little bit, this 1 plus 0.0375, so I can say that a is equal to 1,000 multiplied by 1.0375 to the power of t. So looking at this through the lens of our functions here, of our exponential functions, you'll recognize that c is equal to 1.0375. So every year, or I should say every interest period, which happens to be every compounded period, our amount is being multiplied by 1.0375. So it is a growth. It's just barely over 1. It's going to grow, but it's not going to grow that quickly. So if we were to graph this, a value of c is equal to 1.0375, we get our 0, 1, and then we get our 1, whatever c is. So you're going to see this kind of go up very slowly. The one thing about this function, of course, is we can't really have a negative time, can we? So our function would start here, and we wouldn't have anything to the left, and anything that's negative. Determine the value of the investment after 7 years. Okay, so let's take our function here. Let's try something crazy here. So if I take this, there you go. And take that function there, and now we're going to plug in t. I didn't quite get t. T is equal to 7. So a is going to be equal to 1,000 multiplied by 1.0375 to the power of 7. So on your calculator, if you can plug that in, doing to the power of 7, sometimes you might be using the key that looks like this, like a little bit of a hat. You might be doing x to the y, or you might be doing y to the power of x. Once you've got all your calculator work figured out, your answer will be 1,293.95. Because it's a dollar amount, you're going to round off to the nearest penny, so you're going to round off to the nearest cent. In this case, it's a 5 at the very end, and you should probably put a dollar sign in front because you're answering a question in terms of money. The last one says, how long will it take the investment to triple in value. So triple means times 3. And when I say how long, really we're asking what is my t value going to be equal to. So looking at my a is equal to 1,000 times 1.0375 to the 7th power, we're going to say to triple the investment means that this a value should be 3,000. Okay, and the first thing that you're going to do, oh, this isn't a 7 now, this is a t. Okay, the first thing you're going to do is you're going to divide both sides by 1,000. So when I divide both sides by 1,000, then I get 3 is equal to 1.0375 to the power of t. One thing you'll notice then, for triple, you're always going to get this 3. So it didn't matter what your initial investment was. If your initial investment wasn't even given, then you could just start off with this, right? Because you know that in terms of A is equal to P and all this other stuff, that if they say how long would it take you to double your investment, you could just divide both sides by P, so to speak, and then you could say if it was the word double, then your amount would be 2 times what your principal was. I hope that makes sense for you. Or if it was triple, then we're going to get 3. So that's what we have right now. This is because of that word triple. That's why we have that 3 there. Okay, so now we're going to have to figure out what our time is. There are, I would believe, 3 different ways to solve this question, and one of the ways we're not quite ready for yet. So the first way to solve this one is to graph. You can graph this. You can say y is equal to 1.0375 to the power of x, and you can graph y is equal to 3, and your solution is the intersection. The second way that you could solve this then is you could do a bit of like a guess and check. The guess and check method, so you're going to say, well, what value here of t will give me an answer pretty close to 3. So if you play around a little bit, I find out that 1.0375 to the power of 29 is equal to 2.908, and 1.0375 to the power of 30 is equal to 3.017. So in terms of the question, how long would this take, then the answer would be 30 years. Because at the end of 29 years, you're not there. By the time you hit 30 years, then you're going to cross that 3. Okay. Now the third method that we have, I'll just put this over here, the third method that we have is an algebraic method. Using logarithms. Logs, short for logarithms, and that in fact is our chapter 8, is what it's all about. So your homework assignment then is I mentioned at the beginning of the previous video that this is from, I think this one is 7.1 and 7.2, and then this is 7.3. So you kind of have to move around a little bit in your textbook to check things out, and if you need some extra help, you can probably look inside of 7.1 here or 7.2 here and 7.3 and look at their examples. So I'm all done, and I will see you in class.